I want you to be prepared for third grade. Today we're going to review using the number line as a tool for subtracting in word problems. I want to challenge you to use both counting up and counting back on the number line during this lesson. I will also show you how you can use the virtual or digital base 10 blocks on the iReady dashboard to solve addition and subtraction word problems. Let's get started. Draw the place value chart on your paper. Do a quick draw of base 10 blocks to represent 368 in 3 different ways. So get out a sheet of paper and draw a place value chart just like the one that you see here. Pause the video and restart when you are finished. Remember, you're going to draw 3 different ways to represent the number 368. Let's see what you came up with. First, I'm going to draw 368 at the top so I can see which place value I can decompose. So my number is 368. So in 368, I have 3 hundreds, I have 6 tens, or 60, and I have 8 ones. 368. All right, so let's see if we can show 368 a different way. So this time I'm going to decompose one of the hundreds into 10 tens. So in this way that I'll show 2 hundreds. Now this last 100 I'm going to decompose into 10 tens. So I'm going to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. But I still have my 6 tens from up here, so I have to include those. 10, 20, 30, 40, 50, 60. And then I'm going to keep my same 8 ones. 1, 2, 3, 4, 5, 6. Ones are not working as well. Try this again. 2, 3, 4, 5, 6, 7, 8. 8 there. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. Okay, so let's see what we have now. Now we have 2 hundreds. We have 10 plus 16 plus 6 more here, so we have 16 tens, and we have 8 ones. Do I still have 368? Well, I haven't taken anything away, so I do still have 368. We can see that 2 hundreds plus 10 tens, that would be another 100, so that makes 300, and then I still have 60 and 8. Let's try a different way. So this time, let's go back and let's keep our 300s. So we have 300s, and we had 6 tens, 10, 20, 30, 40, 50, 60. But let me decompose one of those tens. So I'm going to take one of those tens and break it apart into 10 ones. 1, 2, 3. My ones aren't working as well. 2, 3, going away as I'm making them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to do my 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Barely got those on there. So now what do I have? Well, now I have 3 hundreds here. In my tens, I only have 5 tens. And in my ones, I have my 10 ones here. So I have 10 ones plus 8 more. So I actually have 18 ones. Do I still have 368? Well, I can see that I have 300 and I have 5 tens plus another 10 here. So that makes 60. And then I have 8 ones. So that still makes 368. Let's see if we can try one more way. So I'm going to erase my top one up here so we can try one more way. This time we're going to decompose both our hundreds and our tens. So let's make our 300s again. That was in our number 368. And let's decompose one of our hundreds. And we're going to make 10 tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And remember, we also had 6 tens. I'm going to put my 6 tens back because that was in 368. 10, 20, 30, 40, 50, 60. Now we're also going to decompose one of those tens. So I'm going to cross out one of those tens, and we're going to decompose a 10 and give us 10 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have to have our 8 ones from 368. 3, 4, 5, 6, 7, 8. So now let's see what we have this time. This time we have 2 hundreds. And how many tens do we have? Well, we know we have 10 tens here plus 5 more, so that means we have 15 tens. And how many ones do we have? Well, we know we decomposed 1 10 here to give us 10 ones, and then we have 8 more ones left over, so that makes 18 ones. So what do we have here? We have 200 plus 15 tens, so there's our other 100, so that would make 300, and then we have 5 tens plus 1 more tens would make 6 tens, and then we have 8 ones, so we still have 368. So in every representation, we didn't get rid of any of our tens or ones or hundreds. We kept everything. We just decomposed it or represented it in a different way. There's many ways to represent a number. Practice that. Let's try this problem. As you prepare for being a 3rd grader, I would like you to read this problem on your own and answer the questions at the bottom, like you did with your teacher when you were in the classroom. Pause the video and restart after you have answered all the questions. Do not complete the problem, just reread the problem and answer the questions. If your parent is available, you can share your answers with them. Pause the video and come back when you are finished. Let's review the problem together. Kaylee has some shells. During her walk on the beach, she finds some more. Now she has some shells. How many shells did Kaylee have before her walk on the beach? The problem is about Kaylee and her shells. We are trying to find out how many shells Kaylee had before her walk on the beach. This is called a start unknown problem. In order to solve this problem, we have to know how many shells she found and how many shells she has now. Let's look at those numbers. Kaylee has some shells. During her walk on the beach, she finds 132 more. Now she has 215 shells. how many shells did Kaylee have before her walk on the beach? On your recording sheet, find out how many shells Kaylee had before her walk. Remember to write an equation and use the number line tool to count up or back. Pause the video and restart when you are finished. Did you solve this problem with an addition equation? Did your equation look like this? Remember, it is a start unknown problem. That is why we have the missing number first. We don't know the start. We know she finds 132 more shells, and we know how many shells she finds altogether. So we have to count up from 132 to 215. Do you think we will count by hundreds? Since I have 132, if I counted on 100, that would be, you're right, 232, and that would be more than the 215 shells that Kaylee collected. So now I know that I will be counting up by tens and ones. Let's see what our number line and your number line might have looked like. So I'm going to draw my number line. And since I can see in my problem, I have 132 and I have 215 shells, I'm going to start at 132 and I'm going to count up to 215. And however that many that is, that will be my missing number that will go in here. So I'm going to start counting by tens. So this would be 142, 152, 162, 172. What's next? 182. 192, 202, 212. Kind of had to squeeze that in there, didn't I? Now, I made a lot of jumps. Each one of these jumps is plus 10. I could have, if I know my numbers well in my hundreds chart, I could have added a plus 50 and then a plus 30. That would have been quicker than doing all those tens. So when we're thinking about counting numbers, if we can do a bigger chunk of numbers, like 5 tens, 10, 20, 30, 40, 50, that would be a plus 50, and then 30 more, that would go faster when I'm counting. It would be more efficient. So now I'm at 212 here, and I need to get to 215. So now I'm going to count by ones. So 213, 14, 15. And that was plus 1, plus 1, plus 1. So what do I have as my total? Well, I have to count my jumps to find out what my total is. So I have all of my tens that I'm going to count, and I know that I have 8 tens. 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83. So it looks like Kaylee had 83 shells before she started walking on the beach. So she must have started out with 83 shells, and now her total then, after she has the 83 shells, is 83 plus 132 equals 215 shells. Again, that's a start unknown problem because we didn't know the number that we started with. And our strategy there was an addition equation and counting up. Let's see if you tried a different equation. Maybe you decided to write an equation like this. This is a subtraction equation. Kaylee has 215 shells, and if she takes out the 132 shells she found, she will know what she started with, which again is a start unknown problem. So my number line will have to have the number 215 on it. Let's take a look at our number line. So I'm going to have 215 on my number line, but the other number, I don't know what that number is yet. All I know is that I'm going to have to count back 132 to get to that number to find out what it is. So I'm starting at 215 and I'm going to jump back 100 because there's 132 here. So if I jump back 100, what's 215 take away 100? Well, I know that's 115, because if I take away 100 from 200, I have 100. So now I have 115. Now I have to take away 30. So I'm going to jump back 30. 115 take away 110, we'll do 110 at a time, is 105. Then minus another 10, minus 10, minus 10 is 95. These are tricky to count back when we're changing hundreds, so you have to think about that. And then another minus 10 is 85. I could have also done one big jump, and instead of the 10, 10, and 10, I could have said that that was minus 30, if I could do that counting. So now I'm at 85, and I still have to go 2 more because my number said 132. I jumped back 100, and I jumped back 10, 20, 30. Now I have to jump back 2. So if I jump back 2 more, 84, 83. So now I know this number here is 83. I didn't know that before, but I know that now because I counted back 100, 10, 20, 30, 131, 132, which is what my problem told me to do, to count back 132. But you can see that my result, the number of shells that Kaylee had when she started, is what? Yes, we can see that the number of shells Kaylee had when she started was 83 shells. I wonder which strategy you like better. Do you like counting up or counting back? Let's try another problem. Let's try this problem. Students need to paint 500 pumpkins for the fair. They have painted 193 so far. How many pumpkins are left to paint? Write an equation and solve on a number line. I want you to pause the video, then reread the problem and answer the questions at the bottom, and then solve the problem on your recording sheet. Come back and restart the video when you're ready to look at the solution. Did you solve this problem with an addition equation or a subtraction equation? Is it a start unknown problem? No, it is not. We know the students need to paint 500 pumpkins and that they have already painted 193 pumpkins. You could have written an addition or subtraction equation. You can see that these two equations are part of a fact family. We are using the same numbers, but we're changing the order to represent either addition or subtraction. Let's see how we can use the digital base 10 blocks to solve this problem. All right, boys and girls, these are the digital base 10 blocks, which are on the iReady dashboard, your student dashboard. So you can go to these at any time to practice counting with base 10 blocks and decomposing numbers. Mrs. Bauer showed you this in another lesson. So let's think about the problem we just had. there are 500 pumpkins that needed to be painted, and the students had already painted 193. How many more that they need? So if our equation is 193 plus something equals 500, let's work on that one first. So I'm going to put 193 base 10 blocks on my board. So there's 100. I'm going to count 90, and I just click on them. 10, 20, 30, 40, 50, 60, 70, 80, 90, 193, 1, 2, 3. And then I'm going to click on the gridded block here that clears them out so that I can see them that way. Then I'm also going to click on my equation sign here so I can see that I have 193. Now, to find out how many more I need to get to 500, since I want to count up, all I have to do is start adding blocks and stop when I get to 500. So I'm going to change my colors just so I know that this is my second number in my equation. So I have 193, I'm going to add 100, and that would be what? That's 293. And if I click the arrow here, I can see that now I'm at 293. If I click another 100 block, now I'm at 393. Can I do another one and not go past 500? I can. So now I have 493. Now should I do another 100 block? No, that would be 593, and that would be too much. So what about a 10? Can I add a 10? What's 493 plus 10? That would be 503, so that would be too much. So what do I need to add? I need to add some ones. So let's count them. 494, 495, 496, 497, 498, 499, 500. Now let me click on this again so that I can shape up all my blocks. And let's look at our addition equation now. Where's my answer? How many more pumpkins do they need to paint? They need to paint 307 more pumpkins. So that's how I do that with addition. Now if I come over here and I click this arrow, I can clear my screen. I say yes, I want to clear it. And now let's try it with subtraction. So remember, the subtraction equation was 500 pumpkins minus the 193 pumpkins. So let's start with our 500. So I'm going to count 100, 200, 300, 400, 500. Again, I'm going to come over here to my grid and I'm going to clean this up by opening it up like this. And I'm going to bring out my equation. So now I have 500. Well, I need to take away 193. So I can clearly see that I can take away 100. So I'm going to drag 100 down here. And I've got 100. Now let me see. I need to take away 90. I took away 100. Remember, my number is 193, so I have to take away 90. I don't have any 10s here, but I do have 100. So I can break up this 100 into 10 tens. So now let me take away 90. So I'm going to take away 10, 20, 30, 40. See how my number is changing? 50, 60, 70, 80, 90. So now I took away 190 total. I have 100 and I have 90. How many more do I need to take away? You're right, I need to take away 3 more. Well, I don't have 3, but I have a tens block. What can I do with this? Yes, I can break up my tens block into 10 ones, my tens rod, I should say, into 10 ones, and I can take away 1, 2, and 3. So now there's my 193. And let me clean up my area. And I can see down here I had 500. I took away 193. And what am I left with? I'm left with 307. So what an easy way to practice adding and subtracting 3-digit numbers by using the digital tool that's on your iReady dashboard. Try it out. Two classes are trying to earn 750 points for a pizza party. Ricardo thinks Class B needs 148 more points for the party. Is Ricardo correct? Explain your answer with an equation and a number line or base 10 blocks. You can see that Class A has 585 points, and we can see that Class B has 612 points. Pause the video and solve the problem on your recording sheet. Remember, you can also check your work with the base 10 blocks on your student dashboard in iReady. Restart the video when you are finished. Here is your exit ticket. Ashanti shows her work to solve a subtraction problem. Write an equation to represent the problem. Show how she would have solved it on a number line. We can see Ashanti's work here. She has 863 plus 7 equals 870. 870 plus 30 equals 900, and 900 plus 50 equals 950. Think about what the word problem might have been, and go ahead and write the equation that shows why Ashanti would have solved the problem this way. Show how she would have solved it with an equation and a number line. Use your recording sheet to solve the problem, and remember to save your work and turn it in to your teacher. Today we practice solving problems with 3-digit numbers by using different strategies. We used the number line tool and created equations where we practiced counting up and counting back. Which strategy do you like best? We also learned how to use the Base 10 Blocks digital tool on the iReady dashboard to decompose numbers so we can solve problems with 3-digit numbers. I hope you continue to practice with this tool throughout the summer. It will help you become more fluent with the relationship between numbers when solving problems. It will also prepare you for new adventures in math in 3rd grade. Have a wonderful day having fun with math.